Hello, welcome to another Great Car Basic training session. Today we're going to be looking at a function called millis that returns the number of milliseconds that have passed since it's just a millisecond, it just counts milliseconds, and it masks the complexity of timers. This is part 12. We've seen this list before. We've gone through from setting the software up, through flashing some LEDs, generating square waves, reading the ADCs, doing some serial communications, and today we're looking at creating specific delays using a function called millis. Tomorrow we'll be sticking on timers for 2 or 3 sessions and then going elsewhere. What have we got? We've got a PIC microcontroller. It's a 16F18313 connected to a PIC-Kit2 programmer. Could be a PIC-Kit3, PIC-Kit4, and we'll be covering programming later on in these sessions. So what have I got? I've got a little 8-pin chip, and it's got 8 pins. That's why it's called an 8-pin chip, I suppose. That's what we're going to be doing today. So we've got this little board that's like a little low pin count board designed by Chris Roper. In actual fact, the Millis libraries was also written by Chris Roper. So we're going to enable that library that as part of the software. So we're going to enable it. Oh, let's just go back. I'll turn my pen on. We're going to enable it to start with, and then we're going to flash an LED at a specific timed rate, and then we're going to make it do other things. Okay, so with no more ado, we're going to look at the lab just to get us recapped where we are. I have disconnected the little cables that were going out to the serial port. These are all being disconnected, and we've got some LEDs in here. Great, let's just leave that there, and we're going to flash this red LED at the top. So let's look how we're going to do that. We're going to create a new program. I'll just take a copy of where we left it yesterday. Take a copy of this. This is the chip line and the option explicit. That's always the same because that's the chip we're programming. And I'm just going to open up an older demo just to save us time. Okay, I'll open up 4A. There you go. And these are the defines. These are the defines that set up our ports. So we're talking about LEDs on RA1 to RA5, and we've set the directions of these particular ports. Great, we'll paste it into here. With no more ado, I think we should just look at how we're going to write all this code. Well, we can do it through the help, but we need to include a library. So to include something, we would type hash include and then the library name. Okay, with something like this, library. Okay, .h. Now that will then include them from the standard set of libraries that are in Great Car Basic. So let's have a look at those for a moment. I'm going to go into the help, open up the help, and we're going to look at the number of libraries in here. Okay, so library, libraries overview, and these are all the libraries that we've got. There's pages of them, okay? And they go all sorts of sensors, etc., graphics devices, inputs and outputs, etc. All right, software serial, which is really important. So how are we going to do this quite rapidly to keep this at pace? Is we're going to look at a demo, and we have lots of demos, and we're just going to look at a millis solution. Okay, we're just going to take one at random. I'll take that one. And this is a working solution for that for a specific chip. Okay. Well, to be honest, why don't we just use this? We'll just create a new one here. I'm going to change the chip. 313. Is that our chip? Yeah, that's our chip. Option explicit. Here's the library. Include the millis library. Set the port. Well, our port isn't on port A0. It's on. Let's have a look what it's connected to. RA1. RA1. It sets the LED rate to 1000. So let's just see if this works, and I'll save that as 16F 18313. It's quite good actually if this works. Compile that up. It's just compiling it. and that's flashing the LED. You can see that LED is flashing every second. So we've taken a demonstration. Now let's look and decompose that demonstration file. We set the port LED. We set that to RA1. We did that, and we've been doing that constantly. So we're going to refer to that particular port now as RA1. We set our LED rate to 1000 milliseconds. We set the direction of that port, that LED 1 to out, and we set it to an initial value of 0. Okay, that's because we're going to flash it. And then we have cut the working variables. One's called LSTMS, which stands for last milliseconds, and this one is current milliseconds. What we can do, we can quickly replace those so that we can expand those out. Okay, I'm just going to expand those out for you so that we can see them on the screen. Last MS. I'll just replace those for us. Okay, there we go. I've done that in the editor. Okay, so what are we using these variables for? Well, we're going to put the current millis, that's the current incrementing timer. So it starts at 0, and in the first milliseconds it gets incremented to 1, the second millisecond 2, etc., etc. And I'm going to put that value into our variable called current milliseconds. Now, initially I've set last milliseconds to 0, so we do a calculation, and if I just make it very clear by putting some braces around it, just so that you can see it, no other reason, I say, if the current milliseconds deduct the last millisecond is greater than my LED rate, which is 1000, then flash the LED, and then quickly put the current milliseconds into the last milliseconds. So what we've done, we store it away, and then we're doing this comparison all the time to see what's happening. So we can just make sure I haven't introduced a horrible error. And it's flashing. Well, that's really good. So why don't we just add in some other stuff, because this is not doing very much as a piece of code. So let's just delete all that. We'll just tighten that up. So I'm going to add in other code here. And all I'm going to do is add in the code from training session 4 that's on the screen here. I'm just going to add in the reading of the ADC. Okay, we read the ADC here, and we set the LEDs to some value. Okay, so I'm just going to take a copy of that and paste it into our little demonstration here. Okay, let's just indent that to its proper place, just so it looks nice. So what are we doing here? We're reading the LED, and then if it's less than 128, set the LEDs to on or off. Okay, let's just delete that because that's not valid. We don't want to. We're just going to change 2 of the LEDs. I'm going to add that variable because I know that's missing. I can see it's missing in my head. Now I've got a couple of constants to add. Okay, and I can take those constants from here. I'm just going to edit these constants here for us. I'm going to add in these constants here and the directions of those other LEDs because they're not defined in my little test program I'm writing here. They will be. There we go, add them in there and indent them in. Does that look right? Yeah, let's go for it. So, we've got the timer still running. We're doing other code here, and you could write lots of code down here, and we should see that LED right. And if I get my big screwdriver and lower it in on here, as I rotate this, you can see my 2 LEDs are. I'm doing stuff in my other bit of in the blue code that I edited down here. This is the code that's running all the time, and you can see that the timer millis is still running. How is it doing this? Quite clear. There's an interrupt in the background doing the heavy grunting for you. All you need to do is, as shown, is include the millis and read the value in. That's the value that's here. It's a function called millis, and then you can put it into a a variable. And I think millis cycles every 50 days or something. It will run for 50 days before it cycles around and becomes 0. So I wanted to spend a few minutes showing you a function called millis, and I think we'll call that a wrap.